I've noticed some common pitfalls that beginners fall into, so let's talk about what some of those common pitfalls are and how to avoid them with some best practice examples. Pitfall number 1, insufficient or negative draft. I'll open up this first part separately so that we can see it better. It's a bit mind-bendy at first, but think about this for a minute. If the direction your mold comes apart in is straight up and down, and your part doesn't have enough draft, it won't demold properly, and you might end up with some unusable parts. Negative draft is almost impossible to remove with a hard mold. If your plastic hardens and you start trying to pull it out, what do you think will happen? Watch out. There's a handy tool in SOLIDWORKS that will help me visualize this. It's found here under the Mold Tools tab. If you don't see it, right-click, and you can select it to make it visible. The tool I'm going to use is the Draft Analysis tool. I can usually tell by looking, but this tool can help you really zoom in on those problem areas. If your part design requires some negative draft or undercut, your mold will require additional moving parts to your design. I select the parting surface here, and it shows me that my part has 3 degrees of draft. Green is good, yellow needs some work, and red won't work. So if we look here with this undercut, this will call for a separate part of your mold called a pull, so that this whole part can come out correctly. The addition of pulls and other moving parts in your mold definitely add costs, so be mindful of that. Another pitfall to avoid would be long, spindly things and major discrepancies in part thickness, as shown in this sculptural object. Material takes less time to cool the thinner it is, and parts thicker than the recommended maximum start to warp in shape. You can mitigate this with tapering between parts, but you should pay special attention to your manufacturer's guidelines on what's actually possible. Let's say we wanted to mold this sculpture. Thin, spindly features tend to stick in the mold. If you have spindles, try to design them along the parting plane so you have a chance of getting them out. Different thicknesses of parts solidify at different rates, which can make your part shrink at different rates and deform your parts, often outside of tolerance. Also, the longer it takes for a part to be made, the more expensive it is per part. These are some of the reasons why well-designed parts have a nominal wall thickness that is consistent throughout the entire part. The third design pitfall that I want to call out are lattice vessels, like this one. I've had quite a few people ask me how to mold something like this, and I have to explain why this is extremely complex to mold and manufacture. 3D printing helps us create some really cool geometries without the considerations required for mass production. Keeping a design manifold with sufficient draft, fillets, and flow considerations is hard enough without your design being full of holes. I could quite possibly mold this lattice vessel in 2 pieces and assemble it later, but the draft would get very complex. If the design requires this to be a single part, the interior volume makes this a destructive molding part by nature. Of the manufacturing techniques we've covered, what do you think would be the best way to make something like this? The last novice design pitfall I'll cover are improper wall transitions. At first, this looks fine, but on closer inspection, the 2 walls are different thicknesses, and where they meet is incorrect. Maintaining a nominal wall thickness applies to where parts of your model meet up in every direction. If you have 2 same thickness walls meeting up at a 90-degree angle, the hypotenuse right here is too thick. Your corners are going to warp. If you have 2 same thickness walls meet up, but your rounded corner has the same radius applied to both interior and exterior, you can see it does get thicker in that corner. I tend to address this on the sketch level, where I describe the inner wall required, apply the radius, and then offset that line. That way, I can control where the interior wall goes. I also really like the shell command. It's really helpful for a lot of starter projects to help solve the thickness variation issue. At its core, you need to pay careful attention to the way liquid flows throughout your mold, as well as what level of difficulty there will be in ejecting your part once it's solid. Practice makes the master, and prototypes are a lot cheaper to experiment, so go have fun.